In this video, we're going to talk about productivity, a little bit about how we measure it, some calculations we use, and you will be calculating some of this for quizzes and exams in this course. All right, so first, what gets measured gets improved by Peter Drucker. This is very true. We don't know how to improve things if we can't measure them. You look at sports records, the world record in the mile, world record in the marathon, anything like that. We're trying to measure things, and that is how we try to improve those. The same thing happens in business. So we use metrics, KPIs, key performance indicators, all sorts of things to measure our progress to make sure that we're making the right decisions. All right, so the first one we're going to talk about here is single factor productivity. So this is one resource to the goods and services produced. So one in, one out. Multi-factor productivity uses multiple ins for a single output. So this is a better measure of productivity because it looks at all of our inputs. So if we're spending a lot of money on labor, but we're saving it on material, maybe we're better off using that process. The inverse could be true. Maybe something is very cheap from a labor standpoint, but it's very expensive from a material standpoint. Or maybe we're short-sighted. We don't spend the money on our capital. We maybe skip some sort of automation that could have cost a few more dollars, but it would have saved us a lot of material, a lot of energy, a lot of labor. Then our multi-factor productivity will show us that was the wrong decision. All right, single factor productivity, examples you see every day, things like miles per hour, miles per gallon. So these are two different single factor productivity measures that we use commonly, but neither one of them really shows the total inputs and outputs. So if we're driving faster, simple miles per hour, if that's our only measure, then we're making the right choice. However, if you dig a little deeper, driving faster is not the right choice because our miles per gallon goes down. Now we talk about speeding tickets, right? So then if we look at all of our inputs, maybe driving 100 miles an hour is not the right decision. So the calculation, very simple. If we have 600 boxes packed, 20 hours of labor used, we get 30 boxes an hour. Usually no one struggles with single factor productivity calculations. Multi-factor productivity. These can get a little trickier, so we have to think about all of our inputs here. So in this instance, we're going to use a labor cost of $25 an hour, and the material we're using is $20 a ton. We produced 840 units. To produce those 840 units, we used 6 hours of labor and 3 tons of raw material. So then we value each of those 6 hours at $25, and each of those 3 tons at $20 a ton. We add those together. We get 840 units produced for $210 of input. So for each dollar of input, we produced 4 units. That is multi-factor productivity. So the important thing here, the thing that's difficult sometimes for students to catch, is make sure that we're not simply adding 3 plus 6, right? It's not hours plus tons. There's a cost attributed to each of that. Usually you'll see that expressed as a dollar value in this class. All right, the next one, OEE, Overall Equipment Effectiveness. This is one of the gold standards of measuring multi-factor productivity. So we use 3 things. We use availability. So this is uptime. Is the equipment available to run when it should be able to run? Performance. Is the equipment running as fast as it should be running? And quality. Are we getting all of our output good, saleable output, or are we running junk? And we normally express this, or in overall equipment effectiveness, OEE, we always express this as percentages. And we'll go through an example here. So availability, this is the amount of time that equipment is actually running when it's scheduled to run. So any unscheduled downtime, if the machine breaks, we take a penalty. There is no penalty for planned downtime. We do this because preventative maintenance is planned downtime. All equipment must be down. You must change the oil in your car, so therefore that car cannot be scheduled to run during that. However, if you don't change the oil in your car and it breaks down on you, then you do take a penalty for that unscheduled downtime. Availability is runtime divided by planned production time. So in this example, we're going to make coffee today. Your espresso machine is scheduled to be operational from 6 a.m. to 6 p.m. It breaks down at 3 p.m. for 1 hour. What is that availability? So you should have divided 11 by 12 and got 91.67. So we're going to save that. Remember that availability is 91.67. Next, performance. The amount of output run during the runtime versus the theoretical output. There's a penalty for non-productive time and slow cycle time. So if a machine is not being used when it is available, so it can run, but it's not doing anything, or there's a slow cycle time, so it's running slower than possible, you take that penalty. There's no penalty for downtime because that you were already penalized for that in your availability. So performance is your actual output divided by the ideal production rate times your runtime. So if your espresso machine should produce 20 shots per hour, during the 11 hours of uptime it produced 200 shots, what is the performance? 90.90. Okay, so again, it was available, should have been available from 6 a.m. to 6 p.m. That's when it was scheduled. We took a hit for an hour of downtime, so we have 11 hours of available time, and during that time it produced 200 shots when it should have produced 220 shots. So our performance, again, we'll save this number for later, is 90.90. Quality. This is amount of first pass quality versus total produced. There's a penalty for non-conforming or bad output. There's no penalty for downtime or goods not produced. Again, those penalties you already took. So again, first pass quality. This isn't rework. So if you make something and it's wrong and you have to rework it, that's not first pass quality. So we want good quality the first time the equipment touches it. So it's the amount good divided by the total amount produced. So your espresso machine produced 200 shots. Of these, 180 were saleable. So we threw away 20 espresso shots. For whatever reason, apparently this is a very low quality espresso machine. Only 90%, 9 out of every 10 are actually good. So our quality is considered 90%. So then we calculate our OEE. That is A times P times Q. That's the easy way to remember that one. And simply 91.67, 90.90, and 90. You come out with 74.99. So that is OEE. That is how you calculate it. 75% not considered good. But we're not here to judge that. We're just here to learn the calculation. So you should expect that you would, on a quiz or exam, you should be able to calculate availability, performance, quality, and OEE. So those are all 4 separate calculations that you may be asked, as well as single and multi-factor productivity. That's all I've got for this video. Let me know if you have any questions, and have a great day.